Okay, we retain another interesting integral. We've got the integral from 0 to infinity of e to the minus x squared cosine x dx. Okay, this one kind of came up by a series of coincidences. I don't know, I was working on a Laplace transform that I did in a previous video and I noticed the similarity here. And also, just notice the similarity to the Laplace transform here, our Laplace transform formula. It almost makes sense where, like, if this is in the formula, if this is our f of t or f of x, the only difference is in the Laplace transform formula, this value right here should be an x, not an x squared. Well, if we want to do this by Laplace transforms, what we can do is just a U-substitution to clean up that exponent. If I make u equal to x squared, that's going to fix that part. Get a value for x, which is going to be square root of u. Take a derivative on this, so then dx is going to just be 1 over 2 square root of u du. So then we'll go ahead and substitute on it. First, the upper bound, plug in infinity. We're going to have infinity there. Plug in 0, that's just 0. This part is just now going to become e minus u. Our x is square root of u, so now we get cosine square root of u. Dx is going to be du. We'll write it like this, over square root of u. This 2, let's just bring it all the way up front. Let's write this as 1/2 here. And now we basically have this set up for our Laplace transform formula. We've got our bounds are perfect, 0 to infinity. The parameter on here, I can just create this. I can just kind of enter in an s here. In order that we're not changing the problem, we'll just say s equals 1. So when we come back, we can plug that in later on in the video. This here will become, this is just going to be our f of u. Now this looks like a pretty tricky Laplace transform, and actually it kind of is, but we can get a value for this because this is kind of what I was working on before, is something similar to this. So this is going to be okay. So the way we can rewrite this is we'll have our 1/2 in front. This whole thing here is just going to be the Laplace transform cosine square root of u over square root of u. But from here now we just need to work on this Laplace transform. I have a few formulas that can help us out. Let me clean up the board and we'll do this one. Okay, now in previous videos, we derived both these Laplace transforms over here to the right that are going to help us out. I have a playlist on the Laplace transform, so I'll provide a link in the description and you'll find both these in that playlist. So for a starting point, before we get to this right here, f prime of t is the derivative of f of t. So we need some function first. What I'm going to do, and actually, our variable over here is u, so in the formula it's t. Don't worry too much about that. But so for our f of u value, we're going to call the f of u just sine square root of u, so we can put this to use later. And then if I take a derivative on this, f prime of u is just going to be cosine square root of u over square root of u, over 2 square root of u. So I think what I can do to match this up with this, let's just bring this 1/2 into the Laplace transform. Laplace transform works just like an integral, because it's an integral, or it's also a linear operator, so we can bring this inside like this. And now this matches this. This is going to be the f prime u, which is going to allow us to use this second formula right here. But before we do it, let's just get these values here. So first, for f of 0, I can just take this one, plug in a 0. This is just going to become sine of 0, but that's just 0. And then for big F of s, we have this big F notation that this just means the same thing as the Laplace transform of the f of t, or in our case, f of u. So for this is going to be the Laplace transform of sine square root of u. We can use this formula right here. But now that we have everything we need, over to the right, we can just go nuts and use our formula right here. Plug in everything. So we're going to have s times the big F of s, which is all this junk here. And then minus our little f of 0, but that's just 0. So we're not too worried about that. And then we can cancel an s with one of these, and this is going to become, I can write this as square root of s. So maybe just to clean it all up, we can write this, separate this out, 1/2 square root pi over s e minus 1 over 4s. So at this point, we're just about there. We have this thing right here as our Laplace transform that we wanted. The only thing to get back to our solution, we need to use s equal to 1. So let's just come back here, plug 1 in everywhere. So what's going to happen is here we're going to have 1/2. 1 in the denominator is just going to be square root of pi e minus 1 over 4. And then let's just clean it up a little bit. For my final solution is we have just square root of pi over 2. Bring this in the denominator, write it as e 1/4, and that's it. Okay, that's it for today. Thanks everyone for watching. Have a good day.